This video will briefly discuss the formation of beach cusps. It will look at what they are, where they form, and how they're formed, focusing on the two main theories of standing edge waves and self-organization, and then we'll summarize the current debate on cusp formation. Beach cusps are arc-patterned shoreline formations. The landward arcs are called embayments, and the seaward points are called horns, and are made up of coarser material. A single cusp can range from 1 to 50 meters in width. They form in sections of the swash zone and occur most often on reflective, steep, coarse-grained beaches with normally incident waves, but they have been observed on a wide variety of beaches, including both reflective and dissipative conditions, and with sediment ranging from fine sand to boulders. There are two main scientific theories on how cusps are formed: the standing edge wave theory and the self-organization theory. The standing edge wave theory stipulates that cusps are formed by the interaction between normal waves moving towards the shore and waves perpendicular to them that stay near the shore, called edge waves. In this case, they're called standing edge waves because they don't move laterally. They move up and down and against the shore. And because all the movement is vertical, at these points, called nodes, no movement actually occurs. So incoming waves meet these edge waves near the shore. The incoming wave's amplitude is increased if it meets the peak of an edge wave, and decreased if it meets the trough. Because larger waves have more erosive power, cusp embayments are eroded out of the sand where the waves are amplified, and sediment may be deposited as horns where the wave amplitude is diminished. In an attempt to validate this mechanism, scientists checked if edge waves were actually present in the field when cusps form. While some found that they were, others saw no evidence of edge waves. So it seemed that this mechanism could not be the only explanation for how cusps are formed. The self-organization theory developed years later. In this mechanism, the development of cusps starts with a slightly lower point on a plain or beach. When waves move up the swash zone, water is attracted to this lower point and moves up it at a higher velocity than it does the surrounding area, which erodes out the sediment, forming an initial abatement, like a single cusp. Then, the beach begins to rearrange itself to reduce slope variation along the swash zone, and sediment is eroded out next to the initial cusp. At this point, a negative feedback mechanism comes into play. When waves moving up the beach hit the horn of the cusp, the water is slowed. So the first cusp, which is well developed, stops developing as quickly, while the surrounding area develops cusps more rapidly. Scientists have more recently investigated whether the two mechanisms could be compatible, and while some found that the mechanisms could coexist, others concluded that they likely did not. The current consensus seems to be that the self-organization mechanism does not require any forcing or edge waves to form beach cusps, but this doesn't disprove the edge wave theory. So there is still no single theory that can explain beach cusp formation under all observed circumstances, but edge wave interactions and self-organization are the two most likely mechanisms.